Are you feeling wacky? Because things are about to get mad. Welcome to the wild world of my Madlib Generator, where nouns, verbs, and total nonsense collide. In this video, I'll give you a quick demo of the app, show off the backend magic, how it runs through Cloudflare and the OpenAI gateway, and break down the architecture and code behind the chaos. Buckle up, it's gonna get weird. In our demo app, we use the cheapest AI models and caching as a strategy to save costs. The user can ask AI to create the weirdest, most ridiculous story ever, then ask AI to generate a creative image for that story. Given that the user chooses the same words, the app serves the response for both the story and picture from cache. If the user varies their choice of words, the AI will likely generate a new story and image instead of using the cache, with image generation taking noticeably longer. Here's a quick breakdown of the architecture behind my Madlib Generator. The front end is built with vanilla JavaScript and hits two backend endpoints, /Madlib for the story and /image for the matching picture. Both endpoints are handled by a single Cloudflare worker, which routes requests to an AI gateway, also on Cloudflare. This gateway is where the magic happens. It connects to OpenAI's APIs to generate the story with ChatGPT and the image with DALL. But it's not just a pass-through. The AI gateway can serve cached responses to speed things up and reduce token usage. It also logs request details, tracks token consumption, and monitors usage, so I get full visibility into what's happening under the hood. This front-end project is organized for clarity and maintainability. The main logic is encapsulated in script.js, which acts as the bridge between the user interface and the backend APIs. The HTML structure provides input fields for users to enter a noun, verb, and adjective, and buttons to trigger story and image generation. CSS is used separately to style the interface, ensuring a clean separation of concerns. Within script.js, two primary asynchronous functions, generate AI story and generate AI picture, handle the core interactions. When a user clicks the Generate Story button, Generate AI Story collects the user's input, validates it, and sends it to a backend endpoint that generates a Madlib-style story using OpenAI. The resulting story is then displayed in the designated output area, and the image section is revealed if the story is successfully generated. The Generate Image button triggers Generate AI Picture, which takes the generated story as a prompt and sends it to another backend endpoint that interfaces with OpenAI's DALL model. The backend returns a base64 encoded image, which is then rendered in the UI. Both functions include error handling to provide feedback if something goes wrong, such as missing input or server errors, ensuring a robust user experience. Event listeners are registered at the top of the script, binding the button clicks to their respective handler functions. This event-driven approach keeps the UI responsive and interactive. The script also manages UI state by showing or hiding sections and clearing previous outputs as needed, which helps guide the user through the workflow and prevents confusion. Overall, this architecture makes it easy to extend or modify the application. For example, adding new input fields or integrating additional AI features would require minimal changes to the existing codebase. The clear separation between UI logic, API communication, and error handling supports maintainability and scalability as the project evolves. This backend project is architected as a Cloudflare worker, leveraging the edge network to provide low-latency, globally distributed API endpoints. The backend exposes two primary endpoints, one for generating humorous Madlib stories and another for creating images, both powered by OpenAI's models. The backend is built using the itty-router library, which provides a lightweight and efficient routing layer for Cloudflare workers. The root endpoint serves as a simple connectivity check, while the /Madlib and /image endpoints handle the core functionality. For Madlib generation, the /Madlib endpoint expects a post request containing an array of words. The handler validates the input and constructs a prompt that instructs OpenAI's GPT 4.1 nano model to generate a short, humorous story using the provided words. The OpenAI client is initialized with an API key and a base URL pointing to the Cloudflare AI gateway. This gateway acts as a proxy, enabling response caching and reducing redundant API calls for repeated prompts. Image generation is handled by the image endpoint, which accepts a text prompt and uses OpenAI's DALL model to create a 256 by 256 image. The response is returned as a base64 encoded JSON object, making it easy for the front end to display the generated image. Both endpoints include robust error handling, returning appropriate HTTP status codes and messages if the input is invalid or if the OpenAI API call fails. In this video, I walk through the Cloudflare AI Gateway dashboard to showcase logging and caching for my application. Here are examples of real request and response logs, as well as cache behavior in action. Understanding logs can help optimize performance and control costs. A key architectural decision in this project is the use of the Cloudflare AI Gateway. By routing all OpenAI API requests through this gateway, the backend benefits from automatic caching of responses, which significantly improves performance and reduces costs. This design also simplifies API key management and enhances security by keeping sensitive credentials out of the client-side code. Overall, this backend is optimized for scalability, maintainability, and rapid response times, making it an ideal foundation for interactive, AI-driven applications. In this demo, I'm showcasing a real-time view into how my Cloudflare worker performs behind the scenes. The metrics dashboard tracks traffic patterns, response times, and error rates at a glance. It's especially useful for understanding how users interact with the app and spotting performance bottlenecks. Logs are incredibly detailed. They show individual request paths, headers, and status codes, which makes debugging and fine-tuning the worker straightforward. In this part of the demo, I'm showcasing how the app connects to OpenAI's API and how that interaction is reflected in the usage analytics dashboard. Whenever a user sends a post request that isn't served from cache, it gets routed through a Cloudflare worker directly to the chat completions endpoint. These outbound calls are logged in detail, capturing metadata like prompt and completion token counts, latency metrics, and model parameters.